Okay, now, that would be the partial of f with respect to y at x naught, y naught in general. Partial of f with respect to y at any point x, y is just the same expression, but we don't put the subscripts on it, right? So I didn't leave myself much room, but it's the limit as delta y goes to 0 of f of x y plus delta y minus f of x y over delta y. And if you have the formula for your function f of x, y, you can easily evaluate this. Okay? And then, very similarly, what do you think the partial of f with respect to x would be at a point x, y?
F of x plus delta x.
Yeah. First limit as delta x goes to 0, f of x plus delta x y minus f of x y over delta x. Okay? Very easy. Now let's draw the picture. I can expand the picture, so, you know, if I have my x naught, y naught, and actually I don't need to even put subscripts on it. This is some x, y in the plane, right? So wherever we cut the thing, here would be a delta y, and it's going to get a little clumsy drawing the picture. So I'm actually going to draw it with a negative delta x, but okay, here's a delta y, right? Here's the point x, y plus delta y, right? And then here's a delta x. Now that delta x would be negative if x is in this direction, but there's no restriction. Delta x or delta y can be positive or negative, okay? Doesn't make any difference. So now we have our rectangle down in the xy plane, and we can draw our parallelepiped. Okay? Our rectangular parallelepiped. And we can even solidify it, and now we have slopes in the x and the y direction, right? So we have a tangent line in this direction, right? And we have a tangent line in this direction. Well, early first week of the course, I asked you to find vectors, right? And you take the cross product of those vectors, you get the normal, and you get the tangent plane and all that, and that's what we're doing in this chapter now, okay? So you have a good understanding of this picture, okay? So now we have the one slope that's the green segment, right? In this segment, the yellow segment is partial f with respect to y at x, y. Okay? And I'm going to claim kind of important These vectors are in the directions of the tangents. This is a big deal because now if you take the cross product of these, you get a normal vector. So the cross product is normal. And you can puzzle over why these are normal. You know, what's the slope of this vector? What's the slope of this vector? Well, the rise is this, the run is 1, right? And, wait a minute. I wrote those down wrong. Okay, I'm going to go off camera and fix that. It's the partial of f with respect to y should go in the k. Partial should go in the k's. Okay? So I'm just going to change that to k and change that to j and so forth. So I'll do that off camera.